Right. Hi, everybody. We'll see if it works this time. Having constant issues with this Elgato microphone thing. New software up yesterday broke the audio input selection in OBS. So, and of course, I'm looking at my VU meter and everything looks fine, but in OBS it was broken. Anyway, moving on. Right. Hi, everybody in the chat. Okay, so let's start again. Where do we get to? So yes, yesterday then, we were doing a live stream talking about the various different things that we're trying to do with regards to like the job planning. And we came up with this list. Here we are, this list. Right. So, these are the steps that we need to go through in order to do some assembly job, whether it's with a pick and place machine or a manual process. So we created a diagram from that, which looks like this. Ta-da! There we go. So let's just go through this so that everybody can understand what we're trying to build. Okay, so you've got your EDA tool, dip trace, KiCad, whatever, and you make a design in it, or you make a couple of designs in it. And great, you've got those, you send them off to the fab, you get some PCBs back. And then you want to populate some of these PCBs that you've got. So you choose what PCBs you want to populate. It's probably just like one panel, or it could be a few singles that share common parts or whatever. But there's an assembly job that needs to happen. So for each of the designs that are in your EDA tool, you then export the placements. Okay, but your EDA placements list will contain like part and name, and not necessarily manufacturer part number and so on. It'll also contain like the side, like top, bottom of the PCB, as well as the coordinates and rotation and so on. And then for each PCB that you make, there are potentially multiple processes that you need to do in order to do your assembly job. One of which might be use the pick and place machine to put the SMT parts on, and the other machine might be to use your hands to put the through hole parts in. Okay, so these are the processes. So pick and place or manual. And at a later date, there may be other processes that we need to do, and this sort of planning system should be able to cater for those as well at some point. So other things that you might need to do might be put paste on boards, solder paste on boards. Other things you might need to do is optical inspection before reflow and optical inspection after reflow. And these are all separate processes that you need. And once you've decided what processes you need in order to do this job, you then decide how many times you want to do it. So you choose your quantity. And then you choose your variants for the PCBs that you're going to assemble. So in this particular case, we've got two panels, and we've got another panel which has had some PCBs like pushed out of the panel, right? And the panel contains one design repeated 6 times, but we want to make 3 variants of it. Maybe one with blue LEDs, one with red LEDs, and one with green LEDs, say, right? So you've got the different variants. So we use different colour to indicate the different variants. And where the boxes are the same, it means it's the same type of design and same type of variant. Right. So choose your variants. Great. So I've got A, B, and C variants in this example here. A, B, and C. And then you need to build the variants for each design, and building the variants will be using that other tool that we made. Currently I'll be using the other tool, and that is where you take your placements and the list of reference designator for that for the placements that you've exported, and then you cross-reference that with all your part database and the current loadout of what is in the pick and place machine in order to decide what parts need to go onto the variant that you're doing. You do that once for each of the variants. Then you assign the variants to PCB units, which is this bit. I'm saying This one here, number 1, is going to be design 1 variant A. Number 2 is going to be design 1 variant A. Number 3 is going to be design 1 variant B, and so on. So, and these single ones here are separate units as well. Then you choose the process for each part. A lot of this can happen automatically. So, for instance, it's very easy to work out if a part is a through-hole part or not a through-hole part. Your EDA tool has often got settings to allow it to tell you that. Therefore, you can assign all the SMT parts to the pick and place machine process, and all the through-hole parts to a manual process, for instance. And then you create a phase for each process. Now, a phase might be a process might be use the pick and place machine or manually place parts. But for a two-sided board, you need 2 pick and place machine phases, one for the top or one for the bottom, right? And then after you've done that, you might need another phase for all the through-hole parts. So you might end up with 3 phases for this assembly job, right? Then you assign a loadout to each phase. So like loadout A, loadout B, loadout C, one for each phase, right? Then the parts go into the loadout. So all the parts for the top of the PCB go into the loadout for the top of the PCB. All the parts for the bottom of the PCB go into the phase for the bottom, and then all the SMT parts, for instance, go into the third phase for the manual process. Sorry, all the through-hole parts go into the manual process. And then you assign feeders to each of the items that's in the loadout. So for a pick and place machine, that would be like the process of loading parts into the machine. And this would be where you would set up your feeders in your pick and place machine, and then you would put the part in there and everything would be fine, and then that feeder, when it's in the machine, will then have some form of reference that you can put in your loadout, because a loadout is basically just a reference and a manufacturer and part number. A loadout item is a list of these things. And if your pick and place machine only has a few feeders, it might be that you need to set up all the feeders with one set of parts, run the job for each of the units, run the phase for each of these units, and then have another phase for the remaining parts, which it then places. So this is another phase. So then you would assign parts to this new phase. So you've got this, maybe add additional phases somewhere here in this iterative process. Then once you've assigned all your parts to a phase, you've got to choose which order you want to place them in. For manual placements, you could do it via refdes, but that's not very efficient, because then you would take the part and you might use that part in multiple places, and it might be R1 and R73, and you might have touched a whole bunch of other components before you got from R1 to R73. So it's inefficient to open a bag, get some parts, get a part out, put the bag away, get a different bag out, put a part on, and then later go back to that first bag of parts and then get another part from it and put it on. You want to put all the parts from one bag on the boards, on the units, in one go. So you have to touch it as few times as possible. For a pick and place machine, it's different. There are other sort of criteria that make you want to use different placement orderings, such as cost, height, area, complexity. If it's a fine pitch thing, you don't necessarily want to place the fine pitch thing as the first part, because if it doesn't put it down quite right and you need to recalibrate your machine, then that's not good, because now you've got like solder paste on the bottom of this fine pitch part, and you want those to be placed later. So you want to place like something that's small enough so you've got your accuracy right, but also cheap enough and easy to remove, such as like an 0402 resistor. So you want to do your 0402 resistors first, say, and then after that do more expensive parts like gyros, MCUs and things like that. So placement ordering for each phase. Then you generate your artifacts, and the artifacts we decided in the stream the other day were these things. which is a list of phases and repetitions for each phase, part to load out assignments, list of operations for each phase, the feeders that you need to load in the machine, because some of them might already be loaded at this point if you're ready for the first phase, but for the second phase they won't be loaded, or some of them might not be loaded. So you need to know which feeders to load for each given phase, and you want to be able to repeat this process later as well. So you need this loadout list, and then the PCBs to put in the machine or place on your desk. If you're using pick and place machine, you need to know the definition of the panel so that you can tell the pick and place machine like where the units are on the panel and where the fiducials are and things like that. If you're doing manual placement, you don't care about panels at all, you just put parts on, away you go. Your list of assembly variants to PCB units, as in this unit is supposed to be one of these and this one is supposed to be one of these. The ordered list of placements, which we just talked about a moment ago, which is your list of feeders to PCB unit and refdes. So if I've got placements, you would repeat the same placements on this unit as you would here, but you need to know whether you've put this one on and you haven't put this one on yet, and you need to do this one at some point. Right, so this is that was the ordered list of placements and some kind of status, and the status might be like not ready or red or whatever, right? And then eventually you do all these things in this workflow, and eventually the status will be ready to assemble, green, happy days. So then you can run the first phase. So running the first phase might involve a pick and place machine, or it might involve manually opening a bunch of bags and putting through hole and soldering through hole parts into a PCB. During that phase, you need to record which parts have been placed. And there's main two reasons why you need to record it. One, so that you can update your stock counts later to say, I used 10 of these, away we go. Right, decrease the stock by 10. The other reason is because at any given time, during the running of a phase, you might need to replan the job, such as you incorrectly assigned a through-hole part to the pick and place machine, and you hadn't realised or something, or the pick and place machine is being annoying and not placing a particular part properly, and you just decide that it's going to be easier to do this manually. So you would then come back to the workflow and you would apply some changes, and then you regenerate your artifacts, for instance, and then check the status, everything's fine again, and then you carry on running the phase. And if you're resuming the phase, then you need to know which placements have already been placed so that you can then start on the next one, right? Eventually you'll have finished running the phase, and then you check the status again. You say, I've run the phase, everything's good. And then you check the status again, and the status might say, you're done. Great. But if it's a two-sided board, and you're placing parts on the top, you're not done. There's another phase to do, basically. You've got to do the bottom of it, and so on. And then you just keep repeating this until it's done. And that's kind of the general scheme of things. And if we go back to our architecture little diagram that we drew way back when, we had this. And the stuff that we're talking about today, it doesn't really even involve a pick and place machine. It involves like UI planning, EDA integration, and inventory side of things, and some stuff to do with panels, right? And then the actual placing of parts on it is completely separate to the planning side of things. The only sort of overlap between them at the moment, it's not really an overlap, sort of the only interface between them is the artifacts, as in you spit out something that your pick and place machine can take, as in the ordered list of components and the list of feeders, right, and the loadout. and you can give that to your pick and place machine, and it can go ahead and do its thing, and then while it's placing the parts, it can then be recording how many parts it placed, so that it can then later feed back into the planning system, which can then update the inventory system. Right. So that's sort of where we are at the moment with all this. Hopefully that all makes sense. It seems to make sense to me. There's probably things that I missed, but it seems like it's probably good enough to start with. So the other day I was writing some code, which turned out to be too premature. We got to the point of looking into like stuff to do with trees and things like this, and then I realised that it was too early to be writing code, and there was other things that needed to be done, which was this. And then at the beginning of the week, we tried to start on panelization, but we can't do panelization until we organise some of this stuff as well. So, yeah. But after doing all this, after chatting about this and coming up with a list of things in the previous live stream, what was sort of clear to me after doing that is that there's sort of like a status and like a thing that evolves over time, which contains lots of information about the various different things that need to happen, right? And what I was trying to start and build the other day, it wasn't really. It was sort of looking at a very small part of that, which was the sort of building of the job. But you can't really build the job until you've got all the other bits in place and so on. So I went, no, park all that, stash all that code. And I took all the useful bits from it, did a commit, and I've pushed those up. And then I renamed the tool to become Planner. And I've created one test for this, which is create job. Which, if we go back to this thing, is sort of around this. Right. Can we draw? Clicky. Yes. Here we go. This bit. That's sort of where. That's the bit that we're doing right now. Can I do a green pen? Yeah. This is where we're at. Creating a job, it's sort of around this bit. So, you've created this job, and it's probably going to have a status somewhere as well. So I decided that we need a functional test that allows us to create a job, and then have some place to store the name of this job, which is all it does at the moment. And then later we'll add things like, the status, the repetitions, the list of phases for it, the variants and so on. And we're just going to start adding these things into it. But we're also going to build it in such a way that at any time you can go back and change one of these things and then regenerate the artifacts, because that's one of the sort of like key things, is generating these artifacts and checking the status. Right. So that's where we got to. Right, we're 6:30 already. Right, I've got to go out this evening, so this is not going to be a super long live stream today. Probably about another 45 minutes, maybe, something like that. Yeah. Okay, so where are we with them? So we've got this, we've got a test. Let's run it, make sure it works. Yay, it works. So we've got this create job thing, and it's basically like when you run a command with a create and a name, it prints create a job out on the screen, into a trace log or on the screen, and it also generates a file. which we then assert the contents of. The contents of it is currently a JSON file, and it looks like this. So it's basically just a JSON file with one property called name with a value of job 1. It seemed a reasonable place to start. It seemed a reasonable place to start. Right, I'm going to need some water. My throat's a little bit dry. Yeah, let me just pull this up on screen for a moment. I'll be back in a jiffy. I'm just going to grab some water. Rightio, there, we're back. So, yeah, creating a job. And that test passes. That test passes, which is good. The reason it passes is because there's some production code that makes it work. The production code... Yeah, This looks very different to what I was writing the other day. The production code creates like some project thing which is serializable, and it creates a file, and you tell it the directory that the file should be created in when you run this. Because if you don't, it just creates it in the current directory, and then the test doesn't really know what the current directory is for the tool and everything. You could use the current directory, but you don't really want to. You want to use a temporary directory for artifacts when you're running on a test. So you can pass the path over to it. There we go. And then in order to write some JSON file, we need to use Serde JSON to create a formatter with some 4-character indentation, and then serialize the project to a writer, and then do a trace log that says created job. Everything's fine. So that's all it does at the moment. And it's doing this sort of inline in this main method, which of course is no good. And one of the other things that's a bit funky about this at the moment, I haven't really decided one way or the other yet, is that this project is a serializable thing. And it's got Serde attributes and methods and stuff associated with it now, because implementations get created by this Serde derive thing, right? So I'm not sure whether we want to keep the serialization on this object, keep the serialization methods with it, or have another one which is sort of separate from it, like we did with the other tool with some of the things that we need. Don't know yet. Don't know. But anyway, we've got this project, and the project bit, and this is sort of interesting bit. The project is a planning concept. The pick and place machine doesn't care about a project. Let's just remind ourselves of this. This run phase is where the pick and place machine lives. It doesn't care about this project. So for that reason, at the moment, this project is not in the PnP mod. And it might be that we need like a planning mod that this project lives in there. So it feels like now might be a good idea to do that. Let's do it. Because there's likely going to be other things that are going to go in there as well, right? Lib. sure. Right. So let's move that project into that thing. So refactor, move into planning mod. And yeah. Let's see what happens now. Private. Yeah, okay, fine. We're making it public. And there's this thing about public, private fields and so on. I don't like writing getters and setters unless there's I don't know. They're sort of pointless unless you need to actually do anything with them. The only problem is they're not pointless at the exact moment where you need to do something and nothing else is using those getters and setters. But then maybe the design is wrong anyway, and you should have. Yeah. Anyway, so getters and setters, Java thing. So public. Anybody can change it if they've got one, but they can only change it if they've got a shared reference. And if they've got a shared reference, then they're probably okay to change it, really. But should they change it directly, or should there be some tool which sort of changes it to it? And it's like OO versus non-OO. Is it all just code? Yeah. Dilemmas. How to structure code. So with Rust, you sort of have to unlearn OO concepts a little bit because it doesn't work the same way as OO languages do. So people coming from Java are going to find this weird. People coming from Groovy, mind you, which is the JDK language, might not find it quite as weird. Because Groovy creates getters and setters for you automatically so you can access it as if it was a property. Yeah, anyway, right, so what did we do? We moved it. Did it still work? I forgot. Yeah, it does now, there we go. Okay, everything's fine. So we've got this project, and we can do it. I suppose now we need to work out what's next to do. Let's go back to the list. So choose process, choose quantity, repetitions. I don't want to deal with this yet. I don't want to deal with it. No, I'm not doing it. I think we can leave it to later because it doesn't really matter. What we want to do to start with is get one iteration done, and then we can come back to adding repetitions. I think it's going to be more useful to leave repetitions till later. It's not as critical. So choosing variants for each design. Well, there's nothing to do in code for that. You do that in your head. Build variants for each design. You use the other tool to do it. It's done now. Okay, great. Assign variants to PCB units. Okay, here. We can write some code for this. So, in order to assign a variant to a PCB unit, we're going to need a PCB unit. We're going to need a list of PCB units in order to assign things to. Okay, sure. And then I guess the project is going to retain this information. So it feels like we'll have like some new command on this tool. And just remember that we're writing a system, a bunch of bits of code which can manage a project, for which there can be a CLI tool for, and also later a GUI for, to make your life a lot easier. But to get the concepts and to get sort of like the core of the system up, we're just using this CLI tool while we wait for the world of Rust developers to make better user interface systems available to us. And then once we've done all this sort of like low-level detail-y kind of thing, then we can get and make a nice pretty UI using the latest technology of the day. So CLI is for now. So assigning variants to PCB units. Let's go. Right. So let's have a new test. Yeah, let's have a new test. Let's go test. Fun. Does it need to be pub? No. Assign variant to unit. Sure. Now, if you imagine you're in a user interface, right, you've got a list of designs and you've got a list of their variants, and you go, I've got a list of units, PCB units, and you want to go, I want this one to be this one. Click. It's that kind of thing that we're doing. Just one at the moment. You know, maybe you've got multi-select and it does, and maybe you select a bunch on the right and you click one on the left and you apply to the selection, but one at a time is what we need for now. You can apply the same thing to it multiple times. Right. So yeah, so we're going to create a command with some args, and it's going to print something out. Amazing. Create a job. Assigned. What are we going to say in the trace log? Assigned. Assignment created. Now the way I like doing, I don't know if anyone's noticed this, the way I like doing my trace logging, the messages and all this kind of thing, is this is what happened and this is some information related to it, and I try not to mix the two up too much. I try that, not always, but this is what I sort of strive for most of the time. And I also try and make it so these things potentially are machine readable and parsable. So this is what happened. Assignment created. And the assignment that was made would be like a unit, and then we can have some unit reference, which will be unit 1, for instance, and then the design. Let's just say 1 here. Should we give it a name? Let's give it a name. Should we give it a path? Yeah, let's give it a. You'll see why in a bit when we try and do a panel. Okay, let's do the panel one first, because pain. Panels are pain. So we're going to go panel 1, unit 1 is going to be design A, and then the variant is going to be variant A. So the PCB at this panel's location is going to be this design variant. That's what we need to say. Fine. Right, in order to do that, we're going to need some args, a command, and a tracelog path. So we'll grab these things. And because it needs to be able to find the project file, we're going to need the path to the project file, and therefore we need the temp directory for all this stuff and the command itself. So we'll take all that, and away we go. But we don't have the args yet, so let's create some args. Oops. Some of the args need to be the same as before, and they need to be first before the name of the command that you want to do. Otherwise, they will then be command options instead of global options. So trace and path are global options. Right, and yeah, that's enough to run this, right? No. Oh, well, yes. Our method signature is not correct yet. So we need the same method signature as we did before in order to use the question mark operator. And at the end of it, because we've just added that, we need to say OK. Right, great, it fails. Obviously it failed because we didn't specify a command. The way it failed was interesting, actually. We probably need to come back and deal with that, and we probably need to deal with it in the other tool as well. Let's do a fix me. Or it's not really a that's to do. Print help or something like this. Print help if no command specified. Currently, this panics. Fine. There we go. So we need a command. The only command we've got at the moment is create, but we don't want to use that one because we've already created the project. We need to do something else. What are we doing? We are doing some sort of assignment, assign variant to unit. Shall we say assign variant as the command? Honestly, I'm not too bothered about sort of the length of each of these commands because I'm not. You can create short versions of these arguments if you really want to, but so yeah, so we're just going to say assign variant to unit. Fine. And we don't care that it's a very long command name. This should be uppercase, shouldn't it? Because Rust. Is it Control Shift U? Yeah. Oh no. To unit, like so. So this is going to be an enum variant. Oh, was it? No. That's wrong. It's supposed to be. It's supposed to be like this, isn't it? I was right the first time. Everything's fine. I just put it on script. Create. Fine. Now, so the thing that we said we wanted to do was assign this variant to this unit. So we need to specify the design and the variant and the unit. So we'll make it do that, right? Seems reasonable. We're going to go design, sure. Oh, we're writing production code first. Deary me. No. Yeah. Okay, we do it here. We go design equals design what? A. Someone's got a barbecue going. Either that or there's a wildfire. Hope it's not a wildfire. Because it gets a bit burny out here in Spain in the summer. I don't know, it smells a bit. closing the window. I don't want my house to smell of ash. I don't know. All right. Then we said unit. Unit, that was the one. And then we need this sort of path key kind of notation. Which is what this is. Yeah. Oh, it's going to be fun. Right, never mind. Moving on. Yeah, okay, so we've got design variant and unit. Good. So design variant, and then we'll say unit here. Right. Now, we could get all fancy pants and, you know, introduce some kind of type which has get elements and all this kind of thing on it, because our unit is a bit special. Or we could just go with strings right now. However, types, languages and types. You see what we've got? We've got a string and a string and a string. And it's easy to transpose strings. If you've got a function which takes 3 strings, you can pass the wrong string in the wrong place very easily. You wouldn't know anything about it. If you use your compiler to say this string is for this particular purpose, and this string is for this particular purpose, and this string is for this particular purpose, it makes your life a little bit easier. But also it can make it a bit harder as well at the same time. Design and variant. Yeah. Probably okay as being sort of strings for now, but you know, we might change our mind a bit later. But what you can do in Rust is just go struct and go design name and go string like this, right? And what that means is that you can then do this. Yeah. Why do you want to do that? There's a couple of reasons why you might want to do that. One for the transposition thing that I talked about a minute ago. And the other thing is that when you create one of these things, you can use like the new method, or you can use some constructor or whatever like this. And this constructor can do useful things such as remove trailing and leading white spaces. Amazing. Let's just run with this and see where we get to with Surday and its deserialization and all this kind of stuff, and clap and everything. Because I want to know how to do this anyway. It's going to be a useful little thing to work out. And then we've got the design name, and we've got this variant. Do design names variant names? Are they identical, or do they have the same kind of requirements to them? Probably. I don't know at the moment. And therefore the name of this, is it design name? Can we use it here again? I don't know. At the moment they don't do anything. We're just going to go variant name as well. And I guess the constructors here can use the same component to do the trimming and all this kind of stuff, rather than building it into the actual design name implementation itself. So it's probably fine. Sure, we've got that. Then the unit, and this is our funky one. Oh dear, what happened there? I pressed the wrong key. This one is going to be like a unit path, I think. Something like that. Right. Now that's probably going to cause some problems for clap, but it might not. Let's see what happens. Fine, okay, sure, we're going to derive some things from it. Did it derive? Clone. Yeah, okay, fine. Right, so value parser. This is where I thought it might get a bit unstuck. And then we need to deal with this as well. Let's deal with this first by putting a to-do in here. Oh, like that, right? Oh yeah. Yes. And we need to do this, and then we need to say that we have all these things, and that we don't currently do anything with them. Kaplop. Right. Everything's fine. So we just need to deal with this value parsing thing, because we somehow need to go from like a string to one of these little structures that we just had a minute ago. So let's look at one of the error messages and see what it says. Well, this is a long error message. Now these long error messages in Rust can be both good or bad, because they could be a bit like TLDR, right? Too long, didn't read it. Oh, it's too much information. Versus like other languages where they have like this horribly cryptic message which doesn't mean anything to anybody. It has no context whatsoever and doesn't help you fix the problem. The Rust ones seem to be sort of too much on the TLDR side of things than the other way. That's my personal thought. They normally give you all the information you need to help you fix the problem though. They're pretty good like that, but they can be quite long. I mean, look, how many lines of text is this error message? Look at it. I can't even fit it on my screen. The method value parser exists for this, but its trait bounds are not satisfied. Okay. So if it's an argument, it needs to be able to be parsed. Fine. Right. It doesn't satisfy 7 trait bounds. Following trait bounds were not satisfied. Well, I mean, that's pretty crazy. So it says the traits from stir, value enum, and value parser factory must be implemented. What's this value parser factory? Value parser. Probably we should look at the clap documentation for clap value parser at this point. It's a structure. Defines how to convert raw argument value into validated and typed value for use within an application. That's what we want to do. Is there an example with derive? No. Of course there's not. It'd be nice if they cross-referenced the other documentation in the derive crate for all the things that are not in the derive crate. Right, we need a fan. There we go. Still smells very burny outside. Okay, so C value parser. and then you give it. Oh, you give it a method. Okay, so. How do you specify that with clap drive? Let's see if we can work it out. Ah, there's an example. Look, so you go arg, and you give value parser equals value parser, and then you give it a thing. That. And there's helpfully an example. What does it do? From stir for foo. Okay, we'll try this. We'll try that. This looks kind of where we want to go. Yeah, okay, so we basically need to create this and all the other ones from a string. So we need to say value parser is y. Is that too many brackets? Yeah. Okay. And then we'll do the same thing for the other ones, and then we'll have a look and see what the error message is. And yes, everyone knows that I did the wrong one first, didn't they? And then we'll go unit. Sure. Let's see what the error message is now. Well, about the same as it was before. So our little example is you implement fromster for whatever. So we'll try that. Impl fromster for design name string. Sure. Yeah, probably makes sense. Fromster. And then our example was basically just go okay with a whatever. Inner. What the hell? What's S? Oh, I see. Right. So we go okay, and then we go the design name, and then we just put the string in it, right? Right. And is that it? Should be it, right? Can't fail. Yeah, that's how you do it. Right, fine. And then we do the same thing for the other ones, which is a variant name. And then the other one was unit path. So we're literally just copying the string into one of these things. That's all we're doing at the moment. Happy days. It compiles. That's good. Now we broke another test because now we've got this extra argument, which doesn't have a comment on it yet, and it needs to. This would be something like create, assign a design variant to a PCB unit. Sure. And this unit path, is going to be a PCB unit path like this. Should this be called PCB unit path? No, because it's nothing specific to do with a PCB, but we're using this particular unit path for PCBs at the moment. My idea for this is like it's got a key and then a value and then a key and a value, and they're all colon separated, and there should always be two of each. You know, key value, key value, key value. So if you specified something with 3, it would probably be wrong, you know, that kind of thing. Which we can later validate. Somewhere here. Invalid key if, you know, if it doesn't contain enough colons. We'll deal with that. We'll deal with that. Right, PCB unit path. Then what is this one? This is variant. Sure. Let's run this again. Right. So we need to put this in this test here. Something like that, maybe? No, not quite. Oh, the indentation. Okay, fine. We're going to need a new test to say what the help for this new assign variant to command to unit thing is going to look like. So we've already got one for help for create. So now we need another test, which is basically the same as this, but tests the other thing, which is the assign variant to unit thing. And the format of this should look very similar to this. Something like that, and then there's going to be some args for it, which we'll deal with in a minute, and the message should be this, right? And then the arg that we want the help for is this, and we want to say help. Okay, so let's run all the tests again. Oh well, help for, and then whatever the thing was, assign variant to unit, of course, yeah. Right, assign variant. So now we've got the help for this. So now we can see how it wants us to specify things. Design variant unit. Now this unit here, I don't like it like that. I want it to say like unit path or something like we did for the other one. I think it was something like value name and then unit path. Right. There, that's better, because it is specifically different. What are we at now? Right. The other ones are okay though. We've got this variant. Well, I suppose this is a variant name, really, isn't it? Okay, let's do that for this. Yeah, we'll do it for all of them. We'll do it for all of them. Everything's fine. So this is a variant name. And this is going to be design name. And yeah, so now we've got this. So we're going to update the test so that if anyone changes these things in the future, it doesn't break what we've set up. And everyone else who's reading this code knows what it's supposed to do. This is one of these write production code, copy paste into test kind of tests, which you don't normally create, but for things that are like formatted output, where depending on the output of a library, you sort of want to use the library, and you know that you're using the library, but you want to have it so that it's defined once you've used the library, so that if you change the library or you update the library, whatever like this, or you change the implementation of it, that you knew what you were supposed to do, and now you can refactor the production code so that it still meets the same criteria that it used to meet before. Yeah, they're weird doing it like this. It's copy and paste. It just feels wrong, doesn't it? Right. Copy, paste. Everybody saw it. Nobody complained. It's all fine, right? That doesn't look right. This has got to be in line with that. What about now? How about now? Hey, it works. Right, good. So, yeah. Well, yeah, we did the wrong thing here. Fine. And it says not yet implemented. That's good. Cool. Okay. There we go. That's the boilerplate done. Righto. So as you can see here now, we've got these lovely references to design names, variant names, and unit paths, and all this kind of thing now. It's good, isn't it? Instead of strings. It's great. Nice. Happy days. Probably should do it for this one too. I don't know. Maybe we'll come back and poke that. And all these things are sort of like living in here at the moment. Let's move these. Let's move all this. Let's move all this. So we're going to cut this. No, we're not. We're going to refactor move. Can we move? Move. And we're going to put them in the planning mod. Yeah. And we're going to run it again. That's good. Okay. So now that they're in the planning mod, they look like this. Now yeah. I'm just going to leave them there for now. And then we'll bunch a bung more things in here, and then eventually we'll see what we've got in there, and then we'll relocate some stuff. But I'm going to deal with the relocating a bit later. Right, so yeah, this is where we are. Right, so now we've got the three things that we need in order to do what we need to do. So the first thing, I guess, in order to satisfy the test, just trying to satisfy a test. Yes, I know, we're going to add extra things to the test in a bit, don't worry. We're going to do an info message, and we're going to print some stuff out like we said we were going to. And I might poke this around a little bit as well. So what we said we wanted was this message here. be like this, right? So that means we need these things. Oh, that was weird. Did you see what it did then? I went like this. What happened there? Oh. It put another one there. Oh, let me do that again. I didn't know it did that. That's interesting, isn't it? Oh dear. I didn't know it did that. Well, I just learned something about my IDE. Huh. Look at that. Neato. I didn't know it did that. If you try and put brackets around a selection, it puts one on the other end of it. Does it do that if you just press a regular letter? No. Just brackets. Interesting. Okay, moving on. I was supposed to delete first and then put brackets in. Actually, is there a better way to do that? So if you select it, put brackets in and then press backspace. Yeah. Okay. All right then. Fine. That was good. So then, you know, we need to add these things on here, but we're probably going to run into a problem in that it doesn't know how to format these things properly. So the unit is going to be this, and then the design is going to be this, and the variant is going to be this, right? But we haven't implemented anything for these. These are our special types. They're not strings anymore. Now I don't know in Rust yet whether there's this derive for only thing inside it kind of type thing. Let's see what happens. Right, because we've got this design name. Is that a thing? No. Can't drive it. Because a string, it just prints it out. It knows how to format it, right? So we're just gonna add some implementation stuff. Like impl, whoopsie-daisy, impl display for design name. It's gonna be very easy. You go f.write stir self.0. I think. Oh no, dot aster. There we go. That should shut it up for a bit. Yeah, it did. Great. And then we're just going to do the same for the other one. And this one. It's not display name. What is it? It's unit path. And I know some people watching this might be like, this seems a lot of work. Why don't you just use a string? Why don't you just use a string? Because a unit path does not have the same behavior as a string. We do not want the same behavior. We don't want to append to it, for instance. What's the other one? A variant name. Yeah, there we go. It's not a string. It might use a string, but it's not a string. Right. Yay. And Rust is clever as well. It'll just optimize all this out. Like if you look at the generated assembler for this, it'll just be call to strings get reference. That's it. It gets completely optimized out. Right. And we've got the standard result thing going on here. Not sure why it's got that in here. I think that's probably an artifact from the move. Fine. Everything's good. Yeah. Unused import. Where's that unused import? Yeah, it's in the other place. Fine. Go again. Oh, look, and everything passes. Yeah, we're done. We assigned a unit to a thing. No, we didn't. Where's the proof? I mean, it said we did, but we didn't. Where's the proof? Where's the proof? How do you know? What happens if you try to do it again? It would just say it did it. No. So what we've got to do, I suppose, well, how are we going to do the assignment? Like, how are we actually going to do it? Should we have a map of PCB units to variants? But what happens if it's incomplete? Should it just be a list with 2 things in it? Probably. Would a map be better though? Should it be a tree? Because you've got like the sub elements of a panel, right? I don't really want to go there though. I think probably a list. A list is probably simpler. So if we said that when we look at our project file again, the JSON file, which we're currently creating when we do the create command, if we said in that file there's going to now be another property. Let's write it as we think it. Right, expected thing. I've got this job status thing. This project expected. Let me rename this because this is wrong. Project. It used to be called status, but I renamed it to project. I forgot to rename these. Never mind. Everything's fine. Expected project content. Okay, so yeah, so we're going to add this to this one, probably somewhere, maybe here. And then we're going to add the assert, which was this. Right. Yeah. Seems okay. So now we can define what we want to have in here, and this is a JSON file that we're creating. So let's go with assignments, or like unit assignments. Yeah, unit assignments. Should we call this PCB unit assignment? Or should we just go unit assignments? Let's just go unit assignments for the moment. Unit assignments, right? And this is going to be an array. And then it's going to have some things in it. One of the things is going to be an assignment, which is going to be an object with some properties. One of the properties is the unit, I suppose. And we said the unit was this. But, you know, Yeah, let's go like this for now. I was thinking about maybe we should have an object for a panel or something like this here, but I don't think we want to do that. I think we just want to keep this as like a little separate list away from the actual details of the panel and so on. So we've got a unit, and it's this, and then we've got the design, and it's going to be design A, we said, and then the variant is going to be variant A with no comma at the end. Right, so this is what we need to do. This is what we need to do. We need to make this list appear in the JSON file. Okay, I wasn't expecting this error message. System cannot find the file specified. I don't know what file it is. I hate it when you get an error message like this because there's no context. Yes. Like, is it talking about this? Like, does it get here and then fail? Oh my god, look at this, we're using a debugger. I think it is because we didn't get here, did we? Look. Yeah. It is, so it's this. It can't find this thing. Project job 1. Yeah, and then we've got another problem now as well. Because this project file is not even going to exist in order for us to assign stuff to it until we've told it to build it. It just gets more complicated. So then, do we want to do stepwise tests? Problem with stepwise tests is that they take ages to run. You can't run them in parallel, for one. And if something goes wrong, later, it could be because of an earlier test, which apparently worked. Yeah, and they sort of coupled the tests to each other when they're all stepwise. But I don't know. The alternatives aren't great either, though, you know? Creating like a project file and saving it and then telling it to do stuff. I mean, maybe that's okay for this one, I don't know. But why is it having problems finding the file anyway? I mean, well, I suppose, yeah, because it's not ever created it. It's never created it, right? So that's why I can't find it. Because I'm thinking that the file should exist, but it's got the wrong content in it. But the reason I'm thinking that is because another test created it, but that other test created a different directory to the directory that this test is running in, because this temperature is not the same as this temperature. Right. So I feel we're going to go stepwise test, but I don't know. There's probably going to be implications in doing that. I don't know. Because this whole temperature, the whole point behind this temperature thing is you create a temperature, you run a bunch of things, and then the temperature gets cleaned up, right? So what it's going to mean is that we're going to, and then we've got the problem with the trace log as well. Is it going to? Do we want a new trace log for each one? Probably. But the project file should be shared between the tests. Okay, let's see if we can do that. Let's see if we can work out how to do stepwise tests in Rust Cargo. Because I don't think I've had to do this before. I know I've turned off like parallelization stuff before. Rust stepwise test. Sure. Step harness creation, yeah. Should panic, blah de blah. No. No. Rust compiler, no. What are we doing? That's not the right place to be looking at. Yeah. No. Let's just say, instead of stepwise test, ordered. Yeah. Sequentially, yeah, that might be one. Let's see if we can. Exactly, yes, because it runs them in any order it feels like. Create a single test that calls your methods in the desired order. I mean, you could do that. But I don't want one method like that, because I want the reporting functionality in the IDE to tell me which things were run. Because if I had one method that called a bunch of other methods, one test which called a bunch of other methods, then when each one of those things run, you wouldn't get a nice clear indication of which things actually ran and which things failed. You just get the single pass fail at the end of it. And there is a way to, and I've done it before, where the tests don't run unless they got a lock on something. That's how to fix the requirement for this -- test threads one thing. I've got code for that somewhere, but I'll find that again shortly. They run in alphabetical order, it's true. Well, let's have a look at one of these ones. What is this? What is this? Curious. I don't know why that person has said this is okay. Well, I don't see exactly what he's referring to. Yeah. Let's have a look at some test frameworks. Unmaintained, great. Speculate. Okay. RSpec inspired minimal testing framework. Yeah. Okay. Before, after, yeah. Uh-huh. Yeah. This is the kind of thing. I don't know if anyone else has used one of these JavaScript testing frameworks. RSpec is the one that's quite. Is it RSpec or is that a Ruby one? Maybe it was the JavaScript. I can't remember. Anyway, they sort of go it blah 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 blah. This does how stuff happens, and this is sort of what we want. I'm not sure whether using this particular one is a good idea, but something like this. Let's go on crates.io and have a look for test and perhaps framework and search by all-time downloads. Why not? Can we? Maybe it's maybe we should do it like this. No, it just gives the same thing. Fine. Well. Okay, let's go with relevance then. Sure. There's quite a lot of libraries, none of which have got. I'm just looking at the amount of downloads for each one of these. I want to find one with like 1 million or something like that. Huh. What's this? Oh, I've got to go. Anyway, so yes, it's 7:30 now. I'm a little bit late. I've got an appointment. I'll dig into this a little bit more, and yeah, we'll do some more stuff another day. So, just remember, everybody, it's only software. How hard can it be?